Okay, so this will be the second part with regards to sets. Okay, so let's look at this question 11. So in this lesson, same thing, there'll be a total of 10 questions, okay, with of course a bit of increased difficulty as compared to our lesson one. Okay, so in this second part, we'll go through 10 questions as well. So in question 11, it says that an unbiased spinner with 10 numbered sectors is shown. So unbiased basically just means that each number it has an equal chance. Okay. So four of the sectors are shaded, which are one, this, four, and three. This four. Okay, this four are shaded. So when spun, the probability of stopping at any one of the sector is equal. Okay. So it says if the pointer is spun once, find the probability that the number of on the sector is odd. Okay. So in this case, it will just need an odd number. So it's 1, 3, 5, 3, 1, 1. So there are a total of 10 numbers. Okay. And out of these 10 numbers, six of them are odd. So basically, 6 out of 10, simplest form, gives us 3/5. Okay. So moving on, part A, part 2. So the number is a prime number or the shader or the sector is shaded. Okay. So first we look for those which are prime numbers. So 2, 3, 5, 3, 2. Okay. So those are which are prime numbers. Next we look at those which are shaded. So 1, 2, 3. So all the numbers that are being pointed as in red are either prime number or are shaded or are both. Okay. So out of all this, there are total of 8 which are prime number or shaded. So basically, probability is 8 out of 10. So 4/5. So part 3. So it says here the number is even and it's shaded. So it must be both even and shaded. So we just look at those which are shaded and which of them are even. So there are only one which is shaded and even. So in this case, it will be 1 out of 10. Okay. Part B. It says Andy spun the pointer twice. Okay, so find the probability that the pointer stops on the multiple of 5. So on multiple of 5, it will just be this number 5. So what is the probability of it landing on this twice? So ultimately, the first time it will land on the number 5 is probability is 1 out of 10. The second time you'll land on that 1 out of 5 is once again 1 out of 10. So we multiply them together, gives us a probability of 1 out of 100. Okay, last part, part C. It says that Beth spun the pointer twice. Her score is found by adding from the two spins. Find the probability that her score is more than 7. So we need to find the probability that the score is more than 7. So we need to find the probability which adds up gives us more than 7. So ultimately it got to be 8, 9, or 10 were the result. So in this case, the probability of it getting 8 is either we spin both times being 4, the first time being 5, the second time being 3, or the first time being 3, second time being 5. Okay. Next is the probability of it getting 9. So first time being 4, second time being 5, or the other way around. First time being 5, second time being 4. And lastly, in order to get 10, you must have 5 and 5. Okay. So in this case, you just need to find the probability where it lands on 3, lands on 4, and lands on 5. For 3, for probability that lands on 3, okay, this would be 2 out of 10, which is 1/5. Probability that lands on 4, it's also 2 out of 10, which is 1/5. And the probability lands on 5 is 1/10. Okay. So not only you just need to find the probability of each of this combination and we add them together, and that would self will give us our answer. Okay. So first is the we get 4 twice. So it's 1/5 multiplied by 1/5. Second is get a 5 followed by a 3. So that's one turn times 1/5, and get a 3 followed by 5 is 1/5 multiplied by 1 turn. Next, get a 4 and 5, which is 1/5 multiplied by 1 turn, and 5 and 4 is 1 turn multiplied by 1/5. Last, fifth 5 twice, so it's 1 turn multiplied by 1 turn, which will give us a total of 13/100. So that's our answer for this part C. Okay. Next is question 12. So it says this, the diagram shows a one-way road system between junction A and junction D. Okay. So at junction A, the probability that the cars travel along the road AB, so from A to B, is 3/4. While the probability that it travels along AC is 1/4. Following that is uh, at junction B, the the probability that cars travel along BC is 2/5, while the probability that travels along DB is 3/5. Find the probability that that car traveling from point A to D will pass through P. Okay. So in this case, the only thing that's missing, the only probability that's missing is from C to D. So in this case, if you're at point C, and since it's a one-way road, if you're at point C, the only way to travel to point D is through, the only way to move forward is through C to D. Okay. So if you're at point C, the probability of us traveling through CD is 1, because it's definitely going to travel through that. Okay. So in this case, find the probability that a car traveling from A to D will pass through P. Okay. So in this case, so if you are traveling from A to D will pass through P, in order for that to happen, first you must travel from A to B, followed by B to C, and C to D. So in order for it to pass through P, it must go through this path. So the probability of it going to AB is 3/4. And the probability of it going to BC is 2/5. And lastly, the probability of it going to CD is 1. So that itself is our solution, which is the probability of 2/10. Okay, part B. Find the probability that will pass through point Q. Okay, so in this case, in order to pass through point Q, there are a few ways. It must go from AC to CD. That's the first way. Or AB to BC to CD. That's the second path. So in this case, we know the second path, the probability of second path, which is 3/10. We just need to find the probability of AC to CD, which is 1/4 times 1. So in this case, our solution would be 11/20. That's our probability that will pass through point Q. Okay, so that's our part B. Following that, part C. It says an examination for a subject contains 2 modules. To obtain a certificate, a candidate needs to pass at least 1 module. Okay, the probability of passing module 1 and module 2 are P and tutor P respectively. So find in terms of probability uh, of obtaining a certificate. So in this case, one thing which would be helpful is to draw a probability tree diagram. Okay, so for module 1, okay, you'll get either pass or fail. Okay, same thing for module 2 is either you pass or fail. Pass or fail. So these are the possibilities. So in this case, the probability of you passing module 1 is P. And of course, if the probability of you passing one is module 1 is P, the probability of you not passing module 1 is 1 minus P. Okay? So in this case, next module 2, the probability of you passing module 2 is 2/3 P. And so is 1 minus 2/3 P. Same for the other. Okay. So in this case, they ask what is the probability of you obtaining a certificate. So ultimately, you just need to pass one. Okay. So in this case, it's either you pass both, you pass module 1 and fail module 2, or you fail module 1 and pass module 2. So in this case, what we can do is either we can add up this 3, or we can use the reverse, which is 1 minus the outcome that we do not want, which is failing both. Okay. So to make it easier, we will do the one that we will use 1 minus the outcome that we do not want. Okay. So it'll be 1 minus failing module 1, which will be 1 minus P. Failing module 2 will be 1 minus 2/3 P. So in this case, what we'll have is what we'll get is 1 minus, we have to multiply this two bracket. So basically is so this is our probability. Okay. So that's our part one, part A. Okay, moving forward is our part B. It says that if the probability of obtaining a certificate is 2/3 P, it's 2/3, form an equation in P and show that it reduces to this. Okay, so in this case, the probability of us getting a certificate is 2/3, which means 5/3 P minus 2/3 P squared is 2/3. So in order to form the equation, we have to move everything to one side. So we move everything to the right. Okay. So 2/3 P squared minus 5/3 P plus 2/3 equals to 0. So ultimately, next thing is to remove the fraction. So we just need to multiply by 3 throughout. So 2P squared minus 5P plus 2 equals to 0. And that itself is what the question is asking us to reduce. So shown. Okay, part C. Solve the equation. Okay, 2P squared minus 5P plus Q equals to 0, and explain why we reject one of the two solutions. Okay, so 2P squared minus 5P plus 2 equals to 0, and using our solution, using our what we've learned with regards to quadratic equation, the answer we get is P equals to 2 or P equals to half. Okay, so one of the solution we got to reject. So in this case, we got to reject P equals to 2. Reason being, P must be within, is larger than or equals to 0 and smaller than or equals to 1. Therefore, P equals to 2 is rejected. Okay, because all our probability needs to be within the range of 0 to 1. So that should be 0, smaller than or equals to, P is larger than or equals to 0 and smaller than or equals to 1. So therefore, P equals to 2 is rejected. Okay, next question 14. It says here a packet contains a number of flower seed which looks identical but produce flower of different color. Our seeds, okay, produce white flower, one third produce yellow flower, remaining seed produce red flower. Two seeds from different packets are planted. Okay, so in this case, half is white, one third is yellow, then the remaining one is 1/6. Okay, so in this case, in this first seed is this probability, and the second seed ultimately uh, is since it's from a different packet, which means that ultimately the probability stays the same. So our probability stays the same as per what we have. So it's 1/6, white is half, yellow is one third. So it's the same for all. Okay. So in this case, using probability three, using the tree diagram, or otherwise find probability that produce a yellow, both will produce a yellow flower. So for both to produce yellow flower, both must come from that yellow seed. So in order to find that, what we need to do is find the probability of the first pack being the yellow and second pack being the yellow, which is one third each. So the probability of both being yellow will be one third multiplied by one third, which will give us 1/9. The probability of it being both yellow will be 1/9. So B part 2, it says that neither will produce a red flower. So basically, neither will produce a red flower. So uh, will this tree, sorry, neither will produce red flower. So which means is first being white, second being white, first being white, second being yellow, first being yellow, second being white, and first being yellow, second being yellow. So these four are the ones that we want to find. So we just need to find the probability of it for each of it, and we add them all together. So white and white is half multiplied by half. And white and yellow is half and one third. And one third multiplied by half for yellow and white. And lastly, one third multiplied by one third for both being yellow. So in this case, this will get us 0.5 out of 36. Okay, so that's the probability that neither will produce red flower. Lastly, part C, it says here, a third seed is planted and find the probability that two yellow flower and one red flower are produced. So in this case, right now we have three seeds. We want it to be two yellow and one red. So what are the different combinations we have? First being yellow, second being yellow, third being red. Or first being yellow, second being red, third being yellow. Or first being red, second being yellow, third being yellow. Okay. So these are the three different combinations that we have. So ultimately, we need to find the probability of these three combined. So first being yellow is one third. Second being yellow is one third. Third being red is 1/6. And we add first being yellow one third. Second being red is 1/6. Third being yellow is one third. And lastly, first being red is 1/6. Second being yellow is one third. third being yellow is one third. So we just need to find the probability of all three combined. And that will give us a probability of 1/18. So that's for our part C. Okay, next, question 5. It says the diagram shows a circular disc with an arrow fixed at its center O. Okay, so a fair dice, six-sided, is thrown. If the number 1 and 6 are shown, the arrow rotates clockwise 90 degrees. Okay, so if it's 1 and 6, it will rotate clockwise 90 degrees. So otherwise, it stays given that the initial position of the arrow is at A. Write down the probability that the arrow points to A after one throw. So in this case, it turns, the probability of it turning is 2 out of the 6 numbers that it lands on, which is 1/3. So does not turn, it will be 4 of the 6 numbers, which is 2/3. Okay, so that's the first thing that we need to find out. Next is this. It says position A after one throw. So after one throw, if it stays at position A, means it does not land on 1 and 6, which means it does not turn, which means gives us a probability of 2/3. Part B. So it says that lands on position C after 2 throws. So in order for it to land on position C, it must rotate clockwise 90 degrees twice. So that means it must turn twice. So in this case, in order for the probability of it turning twice is 1/3 multiplied by 1/3, which gives us 1/9. Okay. So lastly, as after 2 throws, it lands on position C. So that means it must at least turn, it must turn once. Okay. Which means it's either the first throw turn and the second throw does not turn, or the second throw turns it and the first throw, the first throw does not turn it and the second throw turns it. So we just need to add up the probability together, and the probability of it happening is 4 out of 9. Okay? Next, question 16. Bag A contains 5 red beads, 2 blue beads, while bag B contains 4 red and 5 yellow. And bag C contains 6 blue and 3 yellow. So a bead is first drawn from bag A randomly. If the bead drawn is red, second bag is drawn from bag B. And if the bead is blue, and if a blue bead was drawn from bag A, the second bead is drawn from bag C. So that means if the first bead is drawn as red, okay, the second bead will be from bag B. If the first bead that's drawn from bag A is blue, that means the second bead drawn is from bag C. Okay, so with that, we find the probability of it drawing each individual color. So from bag B, the probability of red beads is 4 out of 9. And the probability of yellow beads is 5 out of 9. So for yellow, for bag C, the probability of blue bead is 6 out of 9, which is 2/3. And probability of yellow bead is 3 out of 9, which is 1/3. Okay. So in this case, they say find the probability that both beads drawn are blue. So which means probability of both beads drawn are blue is 2/7 and multiplied by 2/3, which gives us 4/21. Okay. So next is the beads drawn are of different color. So which means the first bead drawn, it can be red, which is 5/7, and second bead drawn must be yellow, which is 5 out of 9. or first bead drawn is blue, which is top 7, and second bead drawn must be yellow, which is 1/3. And we just uh, add those probability together, and that will give us 31 out of 63. And that's the probability of this, where two beads drawn are of different color. Okay, question 17. Just to take note, in that question, it shows, it writes that it's 5 balls, but instead, just take note it's 6 balls, okay? Because it's numbered 1, 2, 3, 4, 5, 6. Okay. So in this case, it says 2 balls are drawn from a bag at random, one after another, without replacement. Okay. So draw a probability diagram to represent the outcome. Okay. So in this case, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So since it's without replacement, all the same number, all the same number are being crossed out. The first and second ball being the same are being crossed out. Okay. So in this case, if the first number drawn is 2, okay, which is 1 out of 6 possibility, and the second number drawn as 1, which is 1/5 possibility. So with that, it means the probability of it drawing 2 and 1 is 1 out of 30, which is the same for each of it. So this each of it is 1 out of 30. Okay. So in this case, now we have drawn a possibility diagram. Okay. So part B part 1, it says this, that both balls have number more than 3. So in this case, the first ball that is more than 3 are 4, 5, and 6, which is half. And after we take the first ball, okay, if we take either of the ball, okay, the second ball, for it to be fourth, to be more than 3, is also 4, 5, and 6. But after we remove one of the number, it is left with 2/5. So the possibility of it happening is 1/5 for both balls to have more than 3. B part 2. So that neither balls are prime numbers. So in this case, for the first draw, if the ball is not a prime number, that means it must be either 1, 4, or 6, which means it's half. And after removing one ball, where either 1, 4, or 6, we are left with 2 balls which are not prime number. So same thing, 2/5. So what are left with is 1/5. That's a possibility. That's a probability. So lastly, is this the product of numbers is less than 20. So in fact, there are a lot of numbers which are less than 20. So we do the reverse. We find those numbers which gives us more than 20. So in this case, it's either 5 and 6, 5 multiplied by 6, or 6 multiplied by 4, 6 multiplied by 5, 6 multiplied by 6. Or 4 multiplied by 6. So ultimately, this 5 combination would not work. So we know there are 30 combinations. 5 of the combination gives us more than 20. That means 25 of the combinations would work. So which means 25 out of 30, which simplest form gives us 5 out of 6. So that's our answer. Okay. So next is this question 18. It says that Peter has 9 20 cents, 5 50 cents, and $1 in his pocket. He picked 2 coins at random from his pocket, one after another, without replacement. So draw the probability tree diagram. Okay. So in this case, there are 3 possibilities, starting with 20 cent, 50 cent, and $1. So after he picked 1 20 cent, it's still left with 20 cent, 50 cent, and $1. Following that, after he picked 1 50 cent, it will still be same thing, 20 cent, 50 cent, and $1. And after he picked $1, it's left with 20 cent and 50 cent only. So the probability is for 20 cent is 9 out of 15, which gives us 3/5. Then 5 out of 15, which gives us 1/3, and 1 out of 15. Okay. So after that, after we take 1 20 cent, it's left with 8 out of 14, which gives us 4 out of 7. Okay. For 50 cent, it's 5 out of 14. And for $1 is 1 out of 14. For 50 cent, it will be left with 4 out of 14. Sorry. For 20 cent, it will be 9 out of 14. 50 cent is 4 out of 14. And $1 is 1 out of 14. After you pick $1, it's 9 out of 14 for 20 cent and 5 out of 14 for 50 cent. Okay. So part B part 1. Okay. So with the help of the tree diagram, or otherwise find a probability that 2 coins adds up to 20 cent. Okay. So in this case, it's either you pick 50 cent for the first one and you pick 20 cent for the second one. Okay. Or you pick 20 cent for the first one. Okay. And you pick 50 cent for the second one. Okay. So this, each of it are their probability of picking them. Whether is it the first draw or the second draw. And with that, it gives us this probability of 3 out of 7. Okay, so that's for B part 1. B part 2. It says 2 coins have different denomination. So which means this 20 cent and 50 cent, 20 cent and $1, 50 cent and 20 cent, 50 cent, $1, $1 and 50 cent, $1 and 20 cent. So in this case, out of 8 options, 6 of it works. So and 2 of it does not work. And since it's that case, we take the shorter route, which is minusing off the 2 that would not work. So we use 1 minus the probability of those 2 happening. So 1 minus the probability of both being 20 cent, which is 3/5 times 4 of 7. And minus half both being 50 cents, which is 1/3, and 4 of 14. And that will give us 59 out of 105. Okay, so that itself is the probability of us having two coins of different denomination. Next, moving on, we'll move on to question 19. So it says here a bag contains four balls, one marked with the letter B, one marked with letter A, and two with letter L. The balls are picked at random from the bag, one at a time, without replacement. Calculate the probability the first two balls picked have the letter L on them. Okay, so in this case, A part 1, the probability of us getting the first ball being L is 12. And following that, the probability of us getting the second ball being L after removing the first ball, it will be 1/3. So that gives us 1 out of 6. A part 2, that the second ball picked has the letter B. So in this case, the first ball must not be letter B because it is being removed after it picked it. So the first ball not being letter B is 3/4. And the second ball being letter B is 1/3. So in this case, the probability this is 1/4. 3. In this case, find the probability that in that is in the order which the balls are drawn will spell the word B-A-L-L. So the first ball got to be letter B, second ball got to be letter A, third ball got to be letter L, and fourth ball got to be letter L. So in this case, the first ball being letter B is 1/4. Second ball being letter A being 1/3. And the third ball being letter L is 1. Because after removing the B and the A, you are left with two L's. So the probability of you getting L on the third draw is 100%. And your last draw is also 100% because that's the only ball left. So ultimately, that's your probability in that order is 1 out of 12. Okay, so B, part 1. It says a teacher brought 12 sweets to the class, 8 are chocolate, and 4 are fruity. Ben takes a sweet at random, eats it. Jim takes a sweet at random and eats it. So draw probability tree diagram to illustrate it. Okay, so ultimately, the first draw is either chocolate or fruity. Same thing for second draw is chocolate or fruity. Same for the other one, chocolate or fruity. Okay, so the probability of first being the chocolate is 8 out of 12, which simplifies to 2/3. And fruity becomes 1/3. Okay, so after removing one chocolate from the bag and from the total of 12 sweets which the teacher bought, it will be left with 7 chocolate out of the 11 sweet. And fruity will be left with 4 out of 11 sweet. And if the first draw is fruity, okay, the chocolate remains will be 8 out of 11, and fruity will be 3 out of 11. Okay, so that's our probability tree diagram. So next, B part 2. Find the probability that both takes fruity. So if the first is fruity, the probability of it is 1/3. Second is fruity, it's 3 out of 11. So the probability of both fruity is 1 out of 11. And B part 3 is that the probability that they take different sweets. So first being chocolate, second being fruity, or first being fruity, second being chocolate. So first being chocolate is 2/3, second being fruity is 4 of 11, or first being fruity is 1/3, Second ring chocolate is 8 out of 11. So we just have to multiply the individual chocolate and fruity combination in terms of probability, and we add them together. So that gives us a probability of 16 out of 33. Okay, so that's our part 3. Next, question 20. That's our last question. So in this case, it says a lucky draw. There are $200 voucher, four $50 voucher, and six $20 voucher. Two draws were conducted, one after another, without replacement. Okay, so in this case, if the first draw is $100, and the second draw, the probability for $50 is 4 of 11, and 6 of 11. Okay, and the probability of us getting a $50 for the first draw is 4 of 12. Okay, and the rest of it are being filled up. So in this case, they say that they ask for B part 1, they ask calculate the probability that both vouchers drawn are $50. So in this case, we just need to multiply the probability of the first draw being $50 and the second draw being $50, which is 4 of 12 multiplied by 3 of 11. And that will give us 1 out of 11. Okay, so for B part 2, it says find the probability that the total value of two vouchers is more than $80. So if your first draw is 100, doesn't matter what is your second draw, it will be more than 80. If your first draw is 50, second draw must be 50 or 100. And if your first draw is 20, your second draw must be 100. Ultimately, out of these 9 different combinations, 6 of it uh, gives us more than $80. So we know that it's the 3 of it that does not give us more than $80. So in order to calculate, we find those that it does not give us more than $80 because that itself is shorter. So it's 1 minus those probability. So 1 minus first draw being 50, second draw being 20. So which is 4 out of 12 multiplied by 6 out of 11. Next is first draw being 20, second draw being 50. So 6 out of 12 times 12 of 11. And lastly, is first draw being 20, second draw being 20, which is 6 out of 12 multiplied by 5 of 11. So that itself will give us the probability of both draw adding up more than $80. So that itself will give us 9 out of 22. The probability of it being more than $80 for both draw combined is 9 out of 22. So lastly, part C is this. If the rule of the lucky draw is changed such that 3 draws are conducted with replacement, what's the probability of drawing $300 voucher? So right now is with replacement, which means after every draw, the probability stays the same. So in this case, we just need to find the probability that three draws are $100. So in this case, the first draw is there's 100 is 2 out of 12. And the second draw being 100 is also 2 out of 12 because there's replacement. And the third draw is 2 out of 12. So just multiply these 3 together. And the probability of it being three draws, all 3 being $100 is 1 out of 216. And with that, that is the end of our lesson.